Okay, so we're going to make a frequency table. Now, what we've got to do is decide upon classes first, and then we're going to count how many are in that class, and that will be our frequency. I'm also going to talk, though, about relative frequency and how relative frequency relates to percentage. All right, so, and we could do all of these in the same table. So first we need to come up with classes. Now, since these are scores on a statistics test, it makes a lot of sense to make our classes something that makes sense to us. Like, we know that a 70 to a 79 is a C, and we know that an 80 to an 89 is a B, and a 90 to a 99, and actually a 99 to 100 is an A. But we have to make all of our classes the same size. So, so what I'm going to do is make them increments of 10. So the smallest number is a 24. So I'm going to start my classes from 20 to 29. And notice the increment of 10, you can think of the bottom of the class is 10 apart. So this is from 20 to 30. So they each have to be exactly the same length. Same distance from the lower limit to the next lower limit. All right, so 50 to 59. 60 to 69. So in other words, as we do this, we can't put, even though anything below a 60 is a failing grade, we can't put those all in one class because all of our classes have to be exactly the same size. So notice that means that I have to make 100 to 109 its own class just because of the size of each of the classes. They have to be the same. Now, I could have chosen my classes to be different sizes. I could have chosen 20 to 34, for example, to be my first class, and have this one go from 35 to, let's see, it would be 15 apart to the next one to 44. I could do that. I'm sorry, that's not 15 apart. That would have been 49. But this makes a little more sense to go in increments of 10 in this particular example. All right, so frequency. We go and we count how many are in each class. So let's notice there's only one that's in the 20s, so we'll put one here. There's only one that's in the 30s, so we'll put one here. There are none in the 40s, so the frequency is 0. There's one score in the 50s. So the frequency is 1. There are 1, 2, 3, 4 scores in the 60s. And then 1, 2, 3, 4, 5, 6 scores in the 70s. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 scores in the 80s. And then 1, 2, 3, 4, 5 scores in the 90s, and then 3 scores in the 100s. All right, now we should always afterwards make sure that when we add up all of our frequencies, that's the number of data that we have up here. So let's see, 3, 13, 27, 27 and 8. There are 35 listed right here. And if we check our data, there are 35 pieces of data listed here. So we've got them all. All right, now. And notice that it really helped to have them in numerical order when we were listing our frequency rather than trying to go through and count them all out of order. We didn't have to have them in order, but it sure made this one easy. All right, now relative frequency. To find relative frequency, we always take the frequency and divide it by the total number of data. So we're going to take 1 divided by 35 to give us the relative frequency. We'll put this in our calculator and list it as a decimal. All right, so I will round this to 4 decimal places. This comes up as 0.0286. So our next one would be exactly the same relative frequency, 0.0286. This one will, of course, be 0. This one will be 0.0286 again, since 1 out of 35. Now let's do 4 out of 35. 4 out of 35 is going to give us 0.1143. And then 6 out of 35, which will be 0.1714. And then 14 out of 35, ends up being exactly 0.4. And then 5 out of 35 ends up being 0.1429. And then 3 out of 35 is 0.0857. All right, now, if we add up the relative frequency, in the case of the fractions, the relative frequency is going to add up to 35 over 35, or 1. And relative frequency should always add up to 1. However, when we add decimals that we have rounded, we might get slightly less than or slightly more than 1 just because we have rounded things. So be aware that you might add up your relative frequency and might not quite get 1 just because of the differences in rounding. That's okay. Now, you don't want to get significantly different than 1. It should be a little bit over 1 or a little bit less than 1. Just because of rounding, but it shouldn't be significantly different from 1. All right, now percentages. Our relative frequency is just the decimal version of a percentage. So if we move our decimal 2 places, this is 2.86%. So we can expect in this class that about 3% are scoring between 20 and 29 on tests. Same thing with this one. And 0 scoring in here, 2.86 scoring in here, 11.43% scoring in the D range, 17.4% scoring in the C range, a whopping 40% scoring in the B range, 14.29 scoring in the 90 range, although of course, as far as A's, it's really around 22 to 23% that are scoring A's. And that is our frequency table, relative frequency table, and also an expression of percentages.